Hi, and welcome to the webinar. My name's Jeff Underhill, and I'm a Principal Business Development Manager within the Amazon EC2 team. Joining me today is Arthur Petitpierre, who is a Specialist Solutions Architect. And today, we're going to talk about how to get the best price performance for workloads running in Amazon EC2 with the AWS Graviton2 based instances. So with that, let's dive in. AWS offers the broadest and deepest platform choice with more than 275 instance types. This allows us to ensure we have a granular choice of instance family for virtually every workload and business need that our customers may have. At the heart of that portfolio are the general purpose instances, burstable, compute intensive, and memory intensive, but then we innovate along multiple vectors with high frequency processors, high memory footprints, high IOPS for local storage, accelerated computing with GPUs and FPGAs, high networking, and even bare metal instances for customers that need to bring their own virtualization environment. That choice also includes a broadest choice of processors. So Intel Xeon scalable processors make up the majority of the EC2 fleet today. At the end of 2018, we introduced AMD EPYC-based instances, and a short while ago we added the C5A instance to the AMD family, which introduced the AMD EPYC Rome second generation of processors. And at the end of 2018, we also introduced our AWS Graviton processor. And AWS Graviton is going to be the focus for the remainder of this webinar. So what are AWS Graviton processors? It's custom in-house designed silicon based on AWS experience of running cloud workloads at scale for many, many years, built on 64-bit ARM Neoverse cores with targeted optimizations for cloud-native workloads. This allows AWS to innovate across the entire stack on behalf of our customers, right down to the processor that you're running your workload on, the Nitro system that enables us to offload virtualization and provide increasing levels of security and network and storage capabilities. And we can iterate on behalf of our customers across that entire stack to ensure we continue to deliver new innovation and the best price performance for our customers across a variety of workloads. So the very first instance was powered by AWS Graviton processor. That instance type was called A1. It was announced at reInvent 2018. And this was really optimized to provide a cost advantage for scale-out applications. Application examples include web tier, containerized microservices, and people who wanted an ARM-based native software build and test environment. Those instances were available in 6 sizes with a maximum of 16 vCPUs and 32 gig of memory, up to 10 gigabits of networking, and 3.5 gigabits of EBS storage. And it also included a bare metal option, and those were available in 9 regions. And I want you to just remember those data points there, that 16 vCPUs and 32 gig of memory, because as we look forward to Graviton2, you'll see we've made a significant leap forward in capabilities. So here's Andy Jassy on stage at reInvent 2019, talking about those initial A1 instances, how they deliver up to 45% cost savings for scale-out workloads, and sharing some of the customers and partners that have adopted those first generation instances. So A1 was great, and as you saw there, we have a variety of customers and partners already taking advantage of them. But customers wanted to be able to run bigger workloads, a broader variety of workloads, and for that they wanted higher performance instances, larger instances, more memory, more networking. And so that's where today we're broadening the scope of what we can do with AWS Graviton beyond A1. So web and game servers, open source databases, in-memory caches, microservices, all the way through to high performance computing. So here's Andy on stage again at reInvent 2019, introducing the AWS Graviton2 processor and the C6G, M6G, and R6G instances that processor powers. And that's where we'll go into this in much more detail. So the Graviton2 processors, if you compare them to that first generation I mentioned before, they offer 7x the performance. They've got 4 times the number of compute cores, 5x faster memory, double the size of caches. And this is a picture of the chip here on the left. And there's 30 billion transistors, and this is built on a leading edge 7 nanometer technology. It's a huge leap forward over the capabilities of that first generation AWS Graviton processor. So the AWS Graviton 2 based instances, I mentioned these names briefly, but as a decoder ring here, so M is the label used for our general purpose instance family, 6 for 6th generation of those instances, and G being the designator for Graviton 2 based instances. Similarly, we have C6G, which are the compute optimized versions of those, and then R6G, which are the memory optimized versions of those. All three of these instance types are available today. If you just log into the console or via the CLI, you can go and spin up these instances and use them just like any other EC2 instance today. We will add local NVMe-based SSD storage options to these in the near future across all three families, general purpose, compute optimized, and memory optimized. And they offer up to 40% better price performance over current generation comparable x86-based instances. So Graviton 2's role in life is to offer the best price performance within their instance families. They offer the highest performance, 20% lower cost for the same sized instances with the comparable x86 families, and up to 40% better price performance. And as we'll see later, we've got some benchmarks, some real world workload cases, and also some customer feedback that helps kind of give you a good view of the kinds of data that we've been able to collect, but not only that, what our customers have been observing from their time working with Graviton 2. So here's a table of the specs. So this is the M6G table. So you've got size and specifications here. You'll notice it ranges from 1 vCPU all the way up to 64 vCPUs. So where the previous generation stopped at 16, here we go all the way up to 64. In the case of the Graviton processor, the vCPUs are actually CPU cores. They're not a thread. So that means you get great scaling. That also allows us to go down to a medium size with 1 vCPU and maintain that security isolation between instance sizes for our customers. So you've got a smaller option than has been historically available on the x86-based instances. The general purpose instances range from 4 to 256 gigabytes of memory, have up to 25 gigabits of network bandwidth, up to 19 gigabits of EBS bandwidth, and they are 20% lower cost relative to our existing M5 generation. So if you take an M6G large, it's 20% lower cost versus an M5 large. Similarly, C6G, so these are the compute optimized. So the main difference here is the memory footprint. So you have more compute performance relative to the amount of memory offered. Similarly with the R6G, these are memory optimized, so they go the other direction, and you have more memory relative to the compute availability. So these go all the way up to half a terabyte of memory. And you'll notice in the footnote, so the AWS regions that these are available in today include US East, North Virginia, and Ohio, US West with Oregon. We're in Ireland and Frankfurt within Europe, and then Tokyo within Asia Pacific. And we'll continue to expand the footprint and availability of these instance types based on customer feedback. With that, I'd like to hand over to Arthur Petitpierre, who's going to dive deeper into the Graviton 2 processor speeds and feeds, benchmarks, a little bit about our Nitro system, and some of the custom feedback that we've had to date. So with that, over to you, Arthur.
Let's now do a deep dive on the Graviton 2 processor. All our AWS Graviton 2 powered instances are featuring obviously the Graviton 2 processor, but they're all based on the Nitro virtualization platform. The Nitro virtualization platform is a next generation virtualization platform on which we use the Nitro security chip to prevent any firmware from being tampered by an attacker. It is using the Nitro cards that are abstracting away the storage and the network adapters, bringing features about monitoring and securing the platform. And it uses the Nitro hypervisor, which is a lightweight hypervisor loosely based on KVM, which is bringing bare metal-like performance to virtualized instances. The initial Graviton processor was the first AWS attempt at putting an ARM processor in an AWS EC2 instance, making the ARM architecture a first-class citizen on EC2. With the Graviton2 processor, AWS is making a leap forward in terms of size of that processor. It has 4 times the number of vCPUs compared to the initial Graviton processor, a lot more performance, and it's a way bigger processor with 30 billion transistors instead of the 5 billion we had on the initial version. Inside the Graviton2 processor, we have the ARM Neoverse N1 cores, which are ARM v8.2 compliant. We actually worked closely with ARM on the creation of the Neoverse N1, bringing to the table our large experience at running servers in the cloud. So that design brings low overhead of interrupts, virtualization primitives for servers, and is doing very fast context switching, which is something you have to do on a server with hundreds of processes running at the same time. It features all the capabilities that you would find on a server processor, like dual SIMD units, and it even has instructions to accelerate ML inference like int8 or FP16. Another thing that is specific to that processor is that on the EC2 instances powered by Graviton2, every vCPU is a physical core. We don't do simultaneous multi-threading on those EC2 instances, contrary to our Intel-based instances. The 64 cores on the Graviton2 are connected together with a mesh offering up to 2 terabytes per second of bisection bandwidth. It also has a significant amount of cache, with 32 megabytes of last level cache and over 100 megabytes of user accessible cache. From a topology standpoint, the memory on a Graviton2 looks flat. There's no NUMA concern. Every core sees the same path to memory and to other cores, which means that application developers don't have to pay attention to where they allocate the memory, which makes their life easier. When we look at the memory subsystem, it has 8 memory channels, giving it 200 gigabytes of memory bandwidth per second. And that memory is always encrypted with AES 256 keys that are generated at boot time. It also features proprietary compression accelerators that are using a version of the deflate algorithm, and those compression devices are available from 2x large instances and larger, and the drivers for those compression accelerators are open source. Now let's have a look to the performance on the Graviton2. A first benchmark that we run is the SPEC CPU 2017. That is an industry standard CPU intensive benchmark. And the way we ran it was that we loaded those instances with one version of the benchmark per vCPU, so fully loaded systems. And we then compared the performance on a per vCPU basis. For the integer part of the benchmark, when comparing an M5 to an M6G, we could see that the M6G was actually 44% faster than an M5. And for the floating point version of the benchmark, the M6G performed 24% faster than an M5. Now, if we look at a more real case with Nginx, so taking a load balancing use case with Nginx, so the way we've run that is that we generated some load from an EC2 instance use Nginx running on either an M5 or an M6G as a load balancer, load balancing the request to a pool of web servers. Doing that, we observed that we could handle 24% more requests per second on an M6G compared to an M5 of the same size. Now, if we run a benchmark on memcached, so here we use a couple load generators that you can see on the left of the screen, stressing a memcached instance running on either an M5 or an M6G. And on M6G, we observed 43 better performance compared to M5 when running that specific benchmark. But not only was it faster in terms of number of requests per second, but we also observed an improvement in terms of latency, with the latency observed on the M6G being lower even under load than on an M5. Now let's have a look at an HPC benchmark. So our HPC team has run the open source code OpenFOAM, which is a CFD application, on Amazon EC2 C6G instances. There's a full blog post that you can see at the bottom that is detailing the single and multi-node runs on Amazon EC2 instances. And during those runs, they were made without any specific optimization or code modification on OpenFOAM. And we observed that EC2 C6G instances delivered up to 37 better price performance over C family instances. We definitely encourage you to test your application and tell us if you have any question. Now let's have a look to some feedback from our customers when testing or moving into production with Graviton2 based instances. Our partners at KeyDB, so KeyDB is a key value database running in memory, and they observed that M6G could be up to 65% faster than similar sizes of M5. And when it came to the cost of work, M6G could even be up to twice cheaper when looking at the computing cost performance ratio. Another use case is our friends at honeycomb.io. So those guys were early adopters of the Graviton2 platform, and they moved part of their fleet to Graviton2. And doing that move, they observed that they could reduce the size of the C5 fleet that they were using previously, using 30% fewer instances in their new setup. And there's a full blog post from Liz Fong Jones detailing their process and the way they handled the migration. Definitely worth a read if you are interested. Our partners at InterSystem have ported Iris to the Graviton2 processor, and they observed also a significant improvement in terms of performance, and they're looking to extend the coverage of their application on ARM-based platforms. How about a database workload? Our friends at Scylla tested the M6G instances, and Scylla has a high throughput, low latency big data database. With the first generation of ARM-based instances, the A1, it worked and it was supported, but the processor in those instances wasn't able to drive Scylla DB to its peak performance. With M6G instances, it completely changes the game. Now all their CPU and memory-bound workloads are supported, and with an M6G 4x large, they could do 5 times better than what they could do on an A1 instance. With the 64 vCPU that they now have on M6G, they can reach the peak performance from ScyllaDB. AnandTech ran an extensive review of the Graviton2 based instances, comparing them to existing Intel or AMD-based AWS EC2 instances. They explored the memory subsystem, compared the impact of using different compilers, and benchmarked several workloads. Their conclusion is that the Graviton2 based instances are now the best performing of all AWS instances on most of the workloads. I definitely invite you to read the article if you want to have a look to lower level benchmarks. There are a large number of Amazon EC2 customers who tested the M6G instances, and here are some of the feedbacks we received. Our customer AutoBeds was excited to run on the Graviton2 processors. They ran a Java-based workload and got up to 43 better performance on the M6G compared to the previous M5 instances. Mobius Space also tested its Java-based workflow on the Graviton2 based instances, and they observed a performance improvement of 40% compared to the M5 instances, on top of the 20% price discount. And finally, Raygun is an interesting example. Those guys are running .NET Core workload on Linux, and with the Graviton2 based M6G instances, they saw a 30% gain over the M5. Now let's have a look at the Graviton software ecosystem. In terms of operating system, you can run almost any Linux distribution on Graviton2 based instances. So Amazon Linux 2 is obviously supported and optimized for it, but you also have the choice to use Ubuntu or Red Hat or SUSE. And there are even Unix-based operating systems like FreeBSD and NetBSD available on the Graviton2. If you are running container-based workload, Docker has announced support for ARM64 processor a long time ago now. Amazon ECS is available on Graviton2 based instances. Our managed version of Kubernetes, Amazon EKS, is in preview, and Amazon ECR is supporting multi-arch images. In terms of tooling and software, most of the agent provided by AWS, like AWS Systems Manager agent or Amazon CloudWatch agent, are available on Graviton2 based instances. Some of our managed services, like AWS Batch, are already supporting Graviton2 based instances, and you will see additional ones being available in the future. If you are running Java workloads, Amazon Corretto, which is an Amazon supported version of OpenGDK, is available and optimized for Graviton2 based instances. On the partner side, there's been a lot of partner adopting the Graviton2 based instances. On the CI/CD front, Jenkins, GitLab, or GitHub have announced support for Graviton2 based instances. On the security side, people like CrowdStrike, they have implemented their in-memory vulnerability scanner. But you also have Rapid7. Those guys are selling a network scanner that is able to identify vulnerabilities specific to ARM64 based instances. Now let's have a look at what transitioning to AWS Graviton2 based instances means. From a language or toolkit standpoint, all the AWS tools are available, be it the CLI or the agent, and the SDKs are also available, the low-level language ones like C, C++, or the higher-level language ones like Python or Node.js. Interpreted and compiled bytecode languages like Python or Java, they can run without modification. And even .NET Core applications can run on Linux and ARM64, and actually they perform pretty well. As far as compiled applications are concerned, they need to be recompiled for ARM64, which is usually a seamless experience unless there are specific part of it that have been written specifically for Intel-based processors, like using vectorized instructions or things like that, in which case they would have to be ported. In terms of Amazon machine images, as we've seen, most of the Linux distributions are available, and even NetBSD and FreeBSD have ARM64 version. There's no Windows AMIs available though, as there is no commercially available version of Windows Server for ARM64. And if we look at running containers, ARM64 is a first-class citizen in the container ecosystem. So ECS is fully supported on AWS Graviton instances. Amazon EKS is in preview, and you have here a URL that you can use to access the instructions for the preview. ECR now supports multi-architecture images, and you can even build container images for the ARM64 architecture using AWS Code Build. And of course, Docker has support for building multi-arch containers, for example, with BuildX. In terms of transition, the first step is usually to identify all the dependencies for your application. They can be standard libraries, they can be open source libraries, or proprietary ones. So the first step is to scan for that and check whether they all support the ARM64 architecture. If they don't, and if that's not included in the provider's roadmap, be it community supported or proprietary, please let us know. Once your application is built and all the dependencies fulfilled, we recommend to test and run all your usual test bays to ensure that no architecture-specific bug would emerge on ARM64 based instances. And then update your infrastructure as code, like your AWS CloudFormation templates, so that they would allow you to run on ARM64 based instances. Usually it's going to be simple, mainly changing the instance type, the AMI IDs, and potentially the code that you use to bootstrap those instances. Once the infrastructure is ported, perform a blue-green deployment, like having a separated ARM64 base stack alongside the existing one, and then slowly migrate part of the workload to the new stack, checking that everything goes well. If you want to go further, there is an AWS Graviton2 Getting Started guide that is available on GitHub. It has been assembled by our Graviton service team, and it will help you transition and optimize your application. In this guide, we give the right compilers option for the different compiler version, and we definitely recommend to use them as they can make a big difference in terms of performance for your application. Also, using the latest version of operating systems is definitely something we recommend. There has been some patches that have been lately integrated to the kernel that makes it perform really faster on ARM64. And now I'm going to leave you with Jeff for the conclusion.
Thanks, Arthur. So in this webinar, we've introduced you to the AWS Graviton2 processor and the Amazon EC2 M6G general purpose, C6G compute optimized, and R6G memory optimized instances that are powered by this processor. We've walked you through some benchmarks, some real world workload examples, as well as feedback from our customers. And as you can see, for a fairly modest investment, you can get a significant price performance advantage for running your open source workloads on these Graviton 2 based instances. Most workload transitions are seamless. And if you want to find out more, you can check out AWS Graviton 2 today at the link here. On that page, there's additional partner and customer testimonials, links to additional blogs and resources. And with that, let's get to the Q&A.